Okay, so this video is meant for Algebra 2. We have a quiz on Wednesday covering 5.4 through 5.6. And here are some good review problems for you. Also, it's worth bonus, so hopefully you did this. Alright, so first one. We're going to use long division to divide these two. Okay, so look at what we're dividing. We're taking x cubed minus 13x minus 12 and dividing it by x minus 4. Now remember, all your powers of x must be there. This first polynomial is missing the x squared term. So you actually need to rewrite this as x cubed plus 0x squared minus 13x minus 12. So be careful of that, okay, in this on this quiz. And that's going to be divided by x minus 4. So now when I create this long division, x minus 4 goes on the outside. Inside goes the x cubed plus 0x squared minus 13x minus 12. Okay? And notice I left the space because the quotient is going to go on top here, and that is what I'm looking for. So I'll do each step in a different color. So first, we compare x with x cubed, the first term outside with the first term inside. And I ask myself, what do I multiply x by to make it x cubed? And that answer is x squared. So you put the x squared over the second term. It should go over top of the term that has that power in it. But it's the second term because there are two terms out in front, x minus 4. And now we distribute. This x squared goes to both of the terms on the outside. X times x squared is x cubed. Negative 4 times x squared is negative 4x squared. And now we subtract. But subtraction in long division is changing the signs. So this positive x cubed becomes negative. This negative 4x squared becomes positive. We draw our line, and now we just combine down. The x cubes cancel. 0 plus 4 is 4x squared. And I bring down the minus 13x. Okay? Alright, new color. Here we go. So now, again, compare x with 4x squared. What do I multiply x by to make it a 4x squared? Well, I need a positive 4, and x to become x squared has to be multiplied by another x. And again, distribute twice to the two terms outside. X times 4x is 4x squared. Negative 4 times 4x is negative 16x. And now I subtract. And again, subtraction is changing the signs. Positive 4x squared becomes negative. Negative 16x becomes positive. 4x squared cancel. Negative 13 plus 16 is 3x. And the minus 12 comes down. Alright, last step here. X with 3x. To make x become 3x, I need to multiply by a positive 3. 2 times x times 3x is 3x. Negative 4 times positive 3 is negative 12. Change your signs. Negative 3x, positive 12. Cancel, cancel. Your remainder is 0. So, a couple things. The answer to this question is going to be x squared plus 4x plus 3. Now, if there is a remainder other than 0, you would put remainder and then the number. Okay? So again, you don't need the remainder part. Now, another thing to think about is if you get a remainder of 0, that means that x minus 4 goes into this polynomial evenly. So x squared plus 4x plus 3 is another factor of x cubed minus 13x minus 12. So I can do a couple things. I could figure out what these two factors are that make x squared plus 4x plus 3 using our factoring, where c is 3. So this is like another type of problem you could see. So c is 3 and b is 4. And you would find the factors of 3 that make 4, and the factors of 3 are 1 and 3. Since c is positive, same sign, so it's either minus, minus, or plus, plus. The b is positive, so it is plus, plus, and that does give you your 4. So then your other factors are x plus 1 and x plus 3. So again, if I took these two factors in orange and the factor that I divided by in the beginning, I would get this original polynomial. Okay, so that's what all this means. Okay, so that's the importance of getting a remainder of 0. Now, if your remainder is not 0, you just include it in your final answer, r and then number. Okay, that's long division, though. Okay, second one. We're going to use synthetic division to divide here. Okay, all right. So again, notice x cubed, x squared, x number. All of the powers are there. There is no rewriting to do. Now, when you are dividing using synthetic division, when they give you this parentheses x minus 1, you must pretend you're setting equal to 0 and solving. Add 1, add 1. You want to use 1 in the synthetic division. And to use the 1 in synthetic division, it goes on the outside. This L-shaped box gets written down, and you put the coefficients of the polynomial across the top. That would be a 1, a 3, a negative 1, and a negative 3. A 1, a 3, a negative 1, and a negative 3. And then I put this L-shaped box below the last number because this is my remainder box. And to start synthetic division, you bring down the 1. And then when you go diagonally, you multiply by the number on the outside. So 1 times 1 is 1. You combine down, that's 4. Multiply diagonally, that's 4. Combine down, that's 3. Multiply diagonally, that's 3. And again, here you get a remainder of 0. So a couple things. Number 1, the answer to this problem, plus 3 is your constant. Positive 4 is your x term, and positive 1 is your x squared term. So this would be your answer, and again, if there was a remainder, you would put that number, and that would be it. There is no remainder, so you don't need it here. Okay. What this means is x minus 1 is a factor of this polynomial, because you got a remainder of 0. Remainder of 0 means factor. Also, what it means is if this was written like this, f of x equals x cubed plus 3x squared minus x minus 3. This number, remember, is the evaluation of the function at this number. So this also means that f of 1 is 0. If you plugged 1 into the function, you would get 0 out. So remember the connection there between the remainder and evaluating a function. Okay? Understand that idea. And then the last thing is, you could take this polynomial, let me do it in blue, and again, you could further factor it. Because the remainder is 0, this factors further. And if you notice, it's the same as the other problem. C is 3, B is 4. Factors of 3 are 1 and 3. We want a 4. Positive, positive equals 4. The other factors are x plus 1 and x plus 3. So again, it's very powerful when your remainder is 0. You can use synthetic division or long division. Just do what the problem says. And be aware of this evaluation idea here in green, right? This idea right here, that you can evaluate a function by using synthetic division. Okay, next. I'm going to change this problem a little bit. So it says, write a polynomial function with rational coefficients so that p of x equals 0 has the given roots. And we're going to take away the 16. And we're going to change this 19 into a 9i. So this says 1 plus 9i, and then 4. Okay, so those are the two given roots. So again, they're giving you that 1 plus 9i and 4 are given roots. Well, the first thing is you have to understand that some of these roots occur in conjugate pairs. Conjugate pairs. And those are the ones that involve I or a square root. Okay? So 1 plus 9i involves I. If 1 plus 9i is a root, then 1 minus 9i is also a root. Remember, think about the quadratic formula. In the quadratic formula, there's a plus or minus in front of that square root. That's where it comes from. Now, 4 is not an I, it's not imaginary, and it's no square root. So 4 is also a root, but it doesn't have a conjugate pair. So there are 3 roots in this problem. 4, 1 plus 9i, and 1 minus 9i. That means that when I multiply all this out, x cubed is going to be the highest power, right? This means it's a cubic, which is x cubed. Okay? So, in order to do this, I have to write down the factors. So, polynomial of x, p of x equals, if 4 is the root, then x minus 4 is the factor. If 1 plus 9i is the root, then x minus 1 minus 9i is the factor. And if 1 minus 9i is the root, then x minus 1 plus 9i is the factor. And if we multiply these out, we will get the polynomial they're looking for. I'm going to scroll down here to give myself more room. Okay? We're first going to start with these two. Because they're so similar, things are going to cancel nicely. So x to all three, right? X times x is x squared. X times negative 1 is negative 1x. X times 9i is positive 9xi. Negative 1 times x is negative 1x. Negative 1 times negative 1 is positive 1. Negative 1 times positive 9i is negative 9i. And the negative 1 is done. And now negative 9i. Negative 9i times x is negative 9xi. Negative 9 times negative 1 is positive 9i. And negative 9i times positive 9i is negative 81i squared. So things cancel. First, I squared is negative 1, which makes negative 81 positive 81. Positive 9xi, negative 9xi. Negative 9i, positive 9i. All the i's are gone, and we are left with x squared. Negative 1x and negative 1x is negative 2x's. Those are done. And 1 and 81 is 82. Boom. And we bring down the x minus 4. And now we just multiply these two out as we would normally. So x goes to all three things. X times x squared is x cubed. X times negative 2x is negative 2x squared. X times 82 is positive 82x. Now we do the negative 4. Negative 4 times x squared is negative 4x squared. Negative 4 times negative 2x is positive 8x. Negative 4 times positive 82 is negative 328. And now we combine the like terms. X cubed is the only x cubed term. Minus 2 minus 4 is minus 6. X squared. Positive 82 and positive 8 is positive 90x. And then the negative 328. And that is what p of x equals. Okay? So again, through all of this problem, remember the conjugate pair ideas only works with i's and square root roots. Okay? All right, good. Two more here. All right, next one. This is these a little bit longer problems. We're going to find all the roots of the equation. And the first thing we do is we use the rational root theorem. Rational root theorem to find all the possibilities. And all the possibilities come from the factors of the last term, which are plus and minus 1 and 8, 2 and 4, all over the factors of the first number, and that's a 1. When you only have one denominator of a 1, the top numbers are your possible rational roots. 1, 2, 8, and 4. So in this problem, if we have nice roots, it's going to be these from this list. Okay. So what we do here is we plug into our calculator. So we plug in cubed minus 5 squared plus 2 plus 8. And we're looking for one of these numbers that works, that makes 0. And let's see which one it is. I think on the quiz I'm going to give you these numbers. I want to see the list, but I'm going to give you the number that works. And if you plugged in yourself, 2 works. So 2 creates a 0 here. So that means that x equals 2 is one of the roots. And what we will do is we will then use this in synthetic division to bring this cubic equation into a quadratic. So we put the 2 out in front. Put your coefficients of 1, negative 5, 2, and 8. Remainder box there. Bring down the 1, multiply diagonally 2. Combine negative 3, multiply diagonally negative 6. Combine negative 4, multiply diagonally negative 8. 0. this means that 2 works, right? See that? See that connection? So now what I do is I'm going to use the quadratic formula. This is a quadratic. X squared minus 3x minus 4. So I will use the quadratic formula to find the other 2 roots. So to use the quadratic formula, A is 1, B is negative 3, C is negative 4. Quadratic formula says x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And over here, I will do b squared minus 4ac. That is negative 3 squared minus 4 times a times c. This is 9 plus 16, which is 25. And I like 25 because 25 is a perfect square. X equals the opposite of negative 3 is positive 3 plus or minus the square root of 25 all over 2a. A is 1. 2 times 1 is 2. And the square root of 25 goes away and you get just a 5. So when the square root goes away, you must create 2 expressions. 3 plus 5 divided by 2 and 3 minus 5 divided by 2. This is 8 divided by 2, so x is 4. And this is negative 2 divided by 2, and x is negative 1. So these are the 3 roots, 2, 4, and negative 1. And notice they are all from the list above. Okay? So again, think about this as you go through these problems. The possible rational roots, plug it in to see which one comes out to be 0. Again, I might give this to you on the test or quiz, what number to start with. Synthetic division to a quadratic, and then the quadratic formula. Okay. Alright, let's try one more like this. Okay. So we need to find all the zeros of the function. Alright. And I'm actually going to change this problem. Give me 1 second. Okay, so this is the problem I want to look at. Alright, 2x cubed plus x squared plus 1. Alright, so again, I'm going to use the rational root theorem to find all the possible zeros. That's the factors of the last term plus or minus 1 all over the factors of the first number plus or minus 1 or 2, right? And now you take all the numbers on top and divide them by each denominator. So 1 divided by 1 is 1. 1 divided by 2 is a half. So if there are any rational zeros or rational roots, these should work. Some of these numbers. So again, now we plug in, right? So this is the. So I have 2 cubed plus squared minus 1. And something needs to come out to be 0. I will try it. Hopefully you try it as well. Good. And when I wrote this down, this is a plus 1. So negative 1 works. Okay, my green circle is covering it up. That's a plus 1. So x equals negative 1 is a root of this polynomial. So what we will do is we will use this in synthetic division to break it down further. Okay? Okay, so what we'll do is we'll take negative 1 and we'll use it in synthetic division. Now, you need to be careful because you have to make sure all the powers of x are there. Look at this original problem. It's missing the x term. So over here, you need to make sure you think about this as y equals 2x cubed plus x squared plus 0x plus 1, right? Got to fill in that missing power of x. So negative 1 goes on the outside of my synthetic division. My coefficients are 2, 1 for the x squared, 0 for the x, and 1 for the constant. There's my remainder box. Bring down the 2, multiply diagonally negative 2, combine down negative 1, multiply diagonally 1, combine down positive 1, multiply diagonally negative 1, and combine down 0. And there's that remainder of 0. That means that this was truly a root, and you have a polynomial as a result, 2x squared minus 1x plus 1. And we will use the quadratic formula to find the other 2 roots. Okay? So to do this, a is 2, b is negative 1, and c is positive 1. And I'll use the quadratic formula x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. I'll find my discriminant first. B squared minus 4ac. That is negative 1 squared minus 4 times a times c. This is 1 minus 8, which is negative 7. And when you see a negative discriminant, you should be thinking imaginary right away. Alright, so we'll plug in. Opposite of negative 1 is positive 1, plus or minus the square root of negative 7 all over 2a. 2 times 2 is 4. We pull out the I for the negative, which makes the 7 become positive, and 7 cannot really break down. So there's no simplifying here. X equals 1 plus or minus I square root of 7 over 4. So here are 2 of your roots, and negative 1 is a third. Okay. So really, there's only long division, synthetic division, and then the multiplying out with those conjugate roots, and then the rational root theorem. Other than that, I mean, it's all just practicing problems and feeling confident in doing them. Okay. So I'm glad you watched. Hopefully you bring it in for your bonus point, and we will see you on Wednesday. All right.